right, so let's take a look at section 3.6. Okay, so 3.6 is on basically problem solving. And we're going to practice solving some equations using 3 different formulas. Okay, we're going to talk a little bit about profit. Okay, how do you find profit? Say when you have expenses involved and you're selling tickets, so maybe you're making money, but we want to find profit. Distance, speed, or rate, and time. So we might have a problem where somebody travels at 50 miles an hour for 3 hours. How far did they travel? Okay, we'll show you a very basic formula you can use for that. Okay, and the last problem, it's going to be a formula from geometry. Okay, so when we get to that, we'll take a look at it. All right, so I think we're going to start off with profit.
Who's guys in the first line of the thing? You're going to see something that looks just like that.
All right, so the kind of problem we're going to do with profit basically has to do with selling tickets, whether it's tickets to a concert or whatever it happens to be. Tickets, we're going to have a number of tickets we sell. We're going to have a ticket price, okay, how much we pay for tickets. And then we're going to have what our expenses were. Okay, so the only thing we got to do here is pick some letters. What might be a good letter for number of tickets?
T.
We could use T. I'm going to use T for something else, though, but I do like T. But how about number of tickets? N. All right? So it's the number of tickets. Usually that's going to be the number of tickets we sell, okay, for whatever event we have. And then we have the ticket price. What letter could we use for that?
P.
Yeah, you could use P for price or T for ticket price. Which one do you guys want to use? Doesn't matter. P? Okay, use P for price. It's easy to remember that way. And then how about expenses? Q? No.
E.
E? Yeah, that makes sense. Okay, so there's your formula for profit. You take the number of tickets that you sell times the price per ticket. So let's say you sell 5 tickets. Each ticket was $2. How much money did you make in ticket sales?
10.
Yeah, you made $10. All right. Now, let's say if you had somebody performing at a school, maybe you had to rent out the auditorium, so that's going to cost you money. That would be an expense. Okay? Or maybe the band that you hired. The band said, you know what, you got to pay us $500 and we'll go perform at your school. Well, hopefully you sell enough tickets to make back the money you had to pay for the band. Okay? That's the kind of problem we're gonna look at. All right, so this one says a dance costs $800 for the band and other expenses.
Guys, make sure on the bottom of those arrows, make sure you fill in what each thing means. All right, so on your notes, you have the blanks. So you also have the spot to put your what each thing means. So N would be number of tickets. T or P, you guys put P for that, which is fine. That's going to be ticket price. E is expenses. Just so you know what each thing means.
Okay, so for this problem, it's going to cost $800 to hire the band, and maybe the other expenses. Maybe they had to buy like paper plates, cups, soda, stuff like that for the dance. All right, so it costs them $800 to buy all that stuff. Okay, the tickets are $5 each, and it looks like they're going to sell 100 tickets. Right? So we have a couple questions. First thing we're going to figure out is, did they make money or did they lose money? Okay? And we already know what the formula is going to be that we're going to use. So let's plug in and see. Can somebody remind me what that formula is? I'm just going to copy it down right here. Profit equals, what is it? N, so number of tickets, yep. Yep, times P minus E. All right, so let's figure out what our ticket sales were. Okay, N, number of tickets. Ryan, how many tickets did we sell?
100.
Yep, 100 tickets. Okay, so I'm going to plug that in for N. You know what I'm going to do, just so you guys don't get confused, I'm going to write out the word profit. Otherwise, you're going to see P twice, and that's going to be
Yeah, and if
confusing.
you guys wrote it out as as profit, as P, you might want us to add profit in there.
All right, so we'll write it like that, just so you don't get confused. So our profit, number of tickets, P, price per ticket. How much is each ticket for this dance? Yep, $5. All right, so that's how much money we're going to make. Okay, we sold 100 tickets, $5 a ticket, but it cost us money to hire the band. What was the cost to hire the band? Victor?
800.
Yeah, 800. Right, so let's figure out what our profit comes out to. Jalen, what's 100 times 5? Yep, 500. So we made $500 in ticket sales. It cost us $800 to hire the band. So what's going on here? Yeah,
You're losing money.
we were losing money. How much did we lose?
-300.
Yeah, we're going to lose, okay, $300. Okay, 500, take away 800. So, as that was going to be my next question, what does this negative mean? Negative means we lost money. So to answer the question, what was the question? Is there a profit? No, there's not a profit. They lost money. So there is not a profit. Okay, it was actually a loss of 300. Any questions why we lost 300 on that? We'll just plug into the formula and that's what it comes out to. Yeah?
Oh, I said it earlier, actually, I was not going to answer that, but never mind. Like why they get a profit.
Okay, any questions on that? Mr. Roy, do we have the break-even one on here?
Later on.
Okay, that's the next one. Let me just peek at that one. And that's the last one, right?
Yep.
Okay. So another kind of question I could ask here is, all right, well, we know they lost $300, but how many tickets would they have to sell so they didn't lose money? All right, so they at least broke even. Okay, break even means you didn't make money, you didn't lose money. You just kind of, you spent $800, you made $800. You want to know how much to break even? Yeah. Any thoughts on that? All right, let's take a look. Okay, this one we're just going to look at separate because I don't think it's the next one in your notes. Let's see. All right. So it's the same kind of idea. The school still cost $800 to hire the band. Still going to charge $5 a ticket. So all that's staying the same.
You guys, you don't have this one in your notes, so just gotta pay attention to this one.
Okay, we just want the school to break even. Okay, we want them to break even. What did I say break even means? What's your profit if you break even? 0. You don't make money, you don't lose money, you break even. Okay, your profit is 0. Okay, so let's write that down. Profit.
Guys, remember, like I said, the day is just going through this. You don't have this on your note sheet.
Okay, what would I fill in here to solve this problem? Anybody tell me one thing I could plug in for? Oh, Ben?
How much tickets you would need to sell?
That's the only thing we can't plug in for. Because we don't know how many tickets the school needs to sell.
The number, how much it costs for a ticket?
Yep, how much is the ticket price?
$5.
Good. $5. Okay. Anything else I can fill in?
band cost?
Sure, how much is the band?
800.
Yep, we know that. Okay, somebody else tell me one more thing I can fill in for. You don't know the number of tickets. What's my profit?
If you want to break even.
Yep. 800 would mean we're going to make money, but we're going to break even. We're not going to make any money. 0. Okay, we're going to break even. Right? Normally, when we have a number next to a letter, where does the number go? In front or after it? About, Brian? Yeah, it normally goes in front. So let's just write it how we're used to seeing it. Okay, and we got 2 steps to solve this. Devin, what would I do with this negative 800?
Positive.
Good. So add 800. Add 800. That's gone. And what would my last step be? Yeah. Good. Divide by 5. And once I do this out, this is going to tell me how many tickets the school needs to sell. Right? And it should go in evenly, which is good. So the school needs to sell 160 tickets. If they sell exactly that many tickets, then they'll break even. Right? Any question on that? Right? I want to show you guys one other thing you can do. So what did we just use to solve this? All these steps, this whole process. What is this? It's math, but can anybody be more specific? Whenever you're solving for a letter, what kind of math is that? No, think of a subject name. Yeah. Algebra, exactly. Good job. Okay, we used algebra to solve that. Well, there's other ways we can solve this problem besides algebra. Okay, and I don't expect you guys to know how to do this, but I just want to show you something a little different, kind of neat, you probably haven't seen before. Has anybody used one of these calculators before? A little bit? Yeah, some people? Nice. I'm going to show you, I'm going to type in that equation we had right at the beginning here. 5 times something minus 800. Okay, I'm just going to type that into the calculator and see what it tells me. 5 times something minus 800. Now, I know we use the letter n, but on the calculator, it likes the letter x. You guys familiar with x and y when you do your graphing? Okay, calculators, I need to use the x. All right, and I'm going to graph that picture. All right, so let me set it up so you can see it. Let's go like this. And let's go like this. Okay, so that line you see right there, that's the profit. That's us making money. You can see it visually. And what I can do is I can, let's go like this. Let's go down. And let's just set it like that. Not quite what I wanted to do. I'll put it back the way it was. All right, so what I can do here is, as I move along this line, this represents me making money. Okay, if I sell 100 tickets, see how that, maybe you can't see it, but see how it says negative 300? It says negative 300 right there. I'm still losing money. As I sell more and more tickets, what's happening to my profit? It's getting closer to what number? Yeah, it's getting closer to 0, okay? And eventually it's even going to go above 0, and it's going to be positive. Well, the calculator can tell me exactly where it hits 0, okay? And we already know the answer. How many tickets did we have to sell to make a profit of 0? What was it?
800.
Was it 800 tickets? 160? All right, let's see what the calculator says. All right, so I'm just showing you how we can type it in. So I put those little dotted lines in there. The calculator is going to look for an answer where it's close to 0. Everyone see what that says right there? I'll make it a little bigger so you can see it. Let's take this. There. What number does it say right there? 160. 160. All right, so we did the exact same thing using a little bit of technology, okay, using the calculator. All right, so my point here is just to show you there's other ways to do things in math besides just algebra. This is a graphical approach rather than algebra. All right, that's kind of neat. And in other classes, we play with these calculators a lot. We do all kinds of stuff with them. So I thought you guys might like that.
Just like, so if I got one of those calculators, does it actually do the line on it?
Yeah,
It does all the graphic on an actual calculator?
yeah,
Really?
yeah. Yep, in fact, maybe if we have time one day, I'll show you one. I got some of these in my classroom. They look just like this. I have 30 of them that my students in pre-calc use. Yeah, yep, it's a full color screen. Everything you see right here, you have it right in your hand. Yeah, it's pretty cool. You got one right there?
Yeah.
Oh, nice. Yep, that looks like one of the black and white ones. Yep, that one is similar to this one. Does the same thing except it's not color. It's pretty cool. All right. All right. Let's do one more with
Jay,
profit.
you want to give them like a minute
Yeah.
and see if they can not solve it, but set it up?
Yeah. Yeah. Take a minute and set it
Yeah,
up.
take a minute or so to see if you can set it up using that same formula.
All right. How about? Let's see. Who haven't we heard from much today? Ariana, can you tell me what did you have for an equation?
On our paper, it's like a different. I just solved it.
Yep. So you got that? Is that a different example than what's on your paper? Oh, it's different. All right. Let me. Let's see. That could be my fault. How does that one look? Better?
Yeah.
All right. Same kind of problem. Expenses are a little different. How many tickets do you have to sell? Profit's a little different, but same idea. How many of you set it up with the numbers on your paper? All right. Some people. You could do that one, or we could do this one. A little extra practice setting problems up. Okay, Jalen, what's my profit here?
500.
Yep. Profit of 500. Okay, Ariana, what's it say for my price per ticket?
$3.
Yeah, where does that get plugged in for? Not N, P, yeah. Remember, N is the number of tickets, P is price. Okay. My expenses. Okay, what are my expenses here to hire the band? Or in this case, at school play. Yeah, costs $160. And then the only thing I don't know is N, and that's what I'm trying to find. How many tickets? Okay, Maria, what would you do first here to start to get N by itself?
You would multiply and
Remember, if there's any adding or subtracting you need to do, you need to do that before multiply and divide.
add 160.
Good. Add 160. I'll come back to you in a second with multiply and divide because I think we're going to have to do that as well. Okay, 500 plus 160 gives me 660. And do you want to tell me that last step? You were on the right track with what you said?
What? Oh, multiply to get 3n.
Right? Yep, so right now we've got 3. Oh, you want to change the order here to 3n?
It doesn't matter.
Yeah, it doesn't matter. You could if you want. But our goal is eventually we want to get rid of that 3. So,
Divide.
yeah, divide by
3.
divide by 3. And if you like to switch the order, that's okay. That's fine. Okay, and 660 divided by 3. Anybody do that? It'll come out nice. But anybody do that? Logan?
220.
Good. 220 tickets. Anytime we're doing a word problem, make sure we put the right label. In this case, it's either tickets or money. All right. Right, so that's our first type. Does anybody have questions on the profit type of problems? You'll always be given 3 out of 4 of the things. Okay? Whatever 3 you're given, you solve for the 4th one. Okay?
So you want to do this?
Sure. Okay, so Mr. Roy is going to go over the next type of problem.
Guys, on your sheet, I think it says profit formula. Do me a favor and just scratch that out and put distance. Actually, put distance. Oops, sorry, his name. I want you to put distance, rate, time. So it's gonna scratch out on the top there where it says profit formula. So we already did that. That's what we just did. So distance, rate, time. Everybody knows what I'm talking about? Everybody have no idea what I'm talking about? Everyone's good? Cool. All right, so we get distance, rate, time. Same kind of setup, all right, as what we did for the last one. We got some arrows pointing to some blank spaces. Obviously, we're going to fill those in with letters. All right? So you got something that kind of looks like this. All right? First thing we're going to put D equals RT. What do you think the D stands for? Right? D is distance. All right? R is what? Rate. Or speed. And then T is obviously what, guys? Time. All right? So distance, rate, time. How typically, guys, when you're like driving or walking or running or anything like that, what unit do we use to like measure that? If you go for a run, right? Like my wife went for a walk yesterday. She came back and she told me how far she walked. What do you think? What unit did she use probably to say how far she walked? Huh? Right, miles, right? So distance is usually measured in miles. And a lot of the problems we're going to do is usually measured in miles. All right? Or it might be abbreviated MI. How about speed? If you're driving in your car, how do you measure speed, right? Miles per hour. They do it a little bit differently, guys, in the book. They go MI/H. MPH is the same thing, miles per hour, or MI/8. That's what the book usually does. How about time? Hours, right? So in these problems that we do, guys, those are your little hints that I'm going to tell you. All right, distance is miles, speed is miles per hour, and time is usually in hours for the majority of the problems we're going to do. Okay? Let's see what we get here. So the last one we had 4 things. This one has less. This one only has 3. Again, like the last one, you'll get 3 out of the 4. For this one, you get 2 out of the 3. Again, solving for an unknown. You're just taking what we did with equations, and now I have to plug stuff in. All right? So you're going to know 2 out of those 3 variables. All right, so 2A, you guys have something like that looks like this on your sheet, right? 0.75 hours, Sarah, good. So, what's the formula you want to use again, guys? Somebody help me out. D equals RT. D equals RT. So Sarah plans to ride her bike 6 miles in 0.75 hours. At what rate in miles per hour did she travel? Caitlin, what's our D gonna be?
6
Why'd
miles.
you pick 6 miles?
Because distance.
Again, what told you it was distance? Right? Miles, like we just put in our thing, right? Miles is a little hint to say, yep, I'm looking at distance. I don't have to put the MI in my problem. I just gotta put the 6. 6 equals Samantha, what's my rate gonna be? Ah, right, because that's what it's asking for. At what rate? We don't know. That's what we're trying to find. So like Samantha just said, we're just gonna put an R. Last thing is T. What's T gonna be, Zach, in this problem? So I already used my 6. I already used my, we're trying to find rate. What's my time gonna be? Good man. 0.75. 0.75. What can I do here to make this look a little bit more friendly? Okay, I could do parentheses, but I could also do this. 6 equals 0.75 R. Just reverse the order. Because when you guys see problems in the book and stuff like that, you used to having the number first, then the variable. You can flip it, it means the same exact thing. You're not doing anything wrong. All right, you can do that. Now, just like solving an equation. Alex, what am I going to do? Divide by 0.75, right? Always divide by the number that's with the variable. Divide by 0.75, divide by 0.75. Logan, can you do that first in your calculator real quick?
It's 8.
8? So our rate equals 8. 8 what? 8 miles per hour. And there's my final answer. All right? Rate equals 8 miles per hour. So that's these ones aren't too bad because again, it's less numbers. All right? It's only 3 as opposed to the one we did on profit, where there was 4 things. This is only 3. Sometimes, guys, on the homework, on the test on Friday, we might just say D equals 3, R equals 2, find T. All right, it might even not be written out in a word problem like that. It might be just given to you, you got to plug it in and solve. Okay? 2B, or not 2B. All right, guys, take a minute, and everyone has this one on their note sheet, right? John, starts with John. Yes? Take a minute, set it up. Everybody good? Anybody need more time? If you're solving, that's okay. But does everybody set it up? Or at least attempt to set it up? Yes? No? Anybody alive out there? All right, thank you, Ryan. So, Ariana, what you have? 125 equals 25t. All right, so we got 125 equals 25t. Anybody have anything different? You have something different, Jalen? No? Anybody, any brave souls out there have anything different? Okay, let's see. He says D is 125. I agree. How do I know D is 125? Right. Corey caught that earlier. He said, Mr. Roy, but this says miles. That's going to be my distance. Perfect. Put my equal sign. R. What's R stand for again?
Speed.
Rate or speed. How fast you were going. What's the hint? Sabrina.
Oh, the miles per hour.
Miles per hour, right? In this case, it's MPH. Sometimes it'll be MI/H. Means the same thing. All right? Rate, right? How fast you're going. Then T is time. We don't know, right? How long will it take? We don't know. So we're just going to put T. Mr. Gallant, what would I do now to solve this?
Divide both sides by 25.
Divide both sides by 25. Divide by 25. Divide by 25. T equals?
5.
5 what?
5 hours.
5 hours. Right? 5 hours. Here's your final answer. Right? Again, not too bad. Like I said, on the test or on the homework, you may just get it up where you get, it might say find T when D equals 50 and R equals 2. It might not be written out in a word problem like this. We might actually just give you the thing, give you the values, you plug them in. think everybody's feeling pretty good about this. Do people think this is a little bit easier than the ones we just did? Anybody? Not too, maybe just a little bit, because it's a little bit less you have to deal with. All right, but again, it's just taking stuff, plugging it in. All right? So that's it for those two examples. Next, for the back side. Rectangular, solid. Dun, 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 dun. I know. So solid is the total surface area of the 6 sides. All right? So, what am I trying to find? What am I trying to find of this rectangle? What am I trying to find? Gauge. Not the length. The whole formula is for what? Who said it? What? Alexis? Good. Area. Alright? Area. So area is going to equal. We're going to multiply everything in here. Right? We're going to have to use, combine like terms inside of my parentheses, and then I'll use the distributive property. So we're going to have to combine inside first, then distribute. All right, Mr. Hager, I'm not 100% sure in terms of the formula, so I'm going to turn it over to you.
All right. So what I want you guys to think of with this problem is you're building a box. Okay, we're not trying to figure out how much stuff we could fit in the box. Does anybody know what that's called?
Volume.
That's volume. Basically, we're saying, all right, if we wanted to build this box, how much material would we need for each side? All right, the front, the back, the left, the right, top, bottom. Okay, if we were building a box. Okay, so what we're finding here is basically the area of each surface. Okay, the surface area. And how many sides does this box have? 6. Right, so there's 6 sides for each box. For each box. It's a rectangular shaped box. And each side is what shape? A rectangle. Okay, every side is a different rectangle. Right, so we have 6 sides. Actually, it says it right up at the top. Each side is a rectangle. Right, so what we're going to need to do is find the area of each side. Right, so I'll show you a shortcut for how to do that. Okay, does anybody remember the formula for area of a rectangle? Area of a rectangle. Remember how you find it? Yeah? Yeah, you just multiply the 2 dimensions. The length, whether it's the length times the width, all right? So you multiply the length of the rectangle times the width. And how many rectangles we have in this box? 6, all right? Let's start with the one, let's do the one on the left. All right, so I'll kind of color it in so you can see which one I'm talking about. Okay, that's supposed to be the left-hand side of the box. What are the dimensions of that rectangle on the left-hand side? What are the 2 letters we're going to multiply there? Yeah?
H and W.
H and W, all right? So we have H, and then we have W. Those are the 2, all right? Now, I want you to look at the right-hand side. Okay? The 2 shapes in red that I just shaded in, how do they compare to each other? The left-hand side and the right-hand side? Yeah?
They have them both the same.
Yeah, they're the same. Exactly, they're the same. All right? So what we're going to do is we're going to do H times W. That'll give me the one on the left. We have to do H times W. That'll give me the one on the right. So how many of those do we have? 2 of them. Right? That's why we're going to take H times W and we're going to double it. Because there's a left and there's a right. And they're the same thing. Okay? Any questions on that? All right, let's see if what I'll do is I'll get rid of that so then we can do the other sides. All right, let's look at the, let's do the top and the bottom. Okay, here's my top. Okay, I'll just kind of outline it in green so you can see it. What are the dimensions of the top? What are the 2 letters that we would use there? You know what? I think the way Mr. Roy set this up, we're going to put one letter on each line. That was my fault, sorry. Anybody see the two dimensions we're going to use for that rectangle in green? Let's start with this one. What's that line I just drew? That's the what? Good. It's the length. Okay. And what about this line right here? It's like the distance from the front to the back of the box. It's actually labeled somewhere else. Logan? Width. All right, so we've got the length, the width, and what about this one on the bottom? How do those two rectangles in green compare to each other? They're the same thing. One's the top, one's the bottom. Okay, they're exactly the same thing. All right, so we got that. And, whoop, we don't want more green. We want less green. Okay, and then I'm just getting rid of it so we can shade in the rest. So we did the left, we did the right, we did the top, we did the bottom. What are the last two sides we've got? Rose? Front and back. Okay, here's my back. All right, it's shade this in. This one's a little harder to see, but that's the back side. Okay, with those dotted lines. All right, last thing we got to do is figure out what are the two letters you're using for the back side. Yep, Justin, you think you got one? How about this one right here? What's that? That's my height. How about this long one again? Well, width is front to back, but this piece is on the back. Height and length. Height and length. And we have two of those blue pieces that would be identical. We have one in the back, and then we have this one in the front. It's a little harder for me to shade it in to show you. Okay, but we got a piece on the back, piece on the front. So all together we have our formula for the surface area of that shape. Okay, looks a little bit more confusing, like there's more letters, but really, every letter is used twice. All right, so you're filling in width twice, you're filling in height twice, you're filling in length twice. All right, and then we'll solve for surface area. All right, so it's like there's four letters in this one. Surface area, height, width, length. Four things. Okay, any questions on this formula? All right, so that's our last one for today. So we'll try two examples with that, and that'll be it. All right, so this one says find the surface area of a box with a length of 2, width of 5, height of 6. Okay, so they're giving me 3 things. I'm going to find surface area. All right, what I'll do, let's put the formula back up so we can kind of see it as we go through it. All right, so I'm going to abbreviate surface area SA. Is everyone okay with that? SA, surface area. All right. What's the first thing that comes right after the equal sign? We didn't have to write this one down. Yeah, just saying. Yep, we get the 2. Then in parentheses, H times W. Okay, Victor, what's H in example 3A? Yep, H is 6. And can you tell me W? Good, W is 5. So 6 times 5 plus, anybody tell me what times what is going to come next? Good, we got L times W, 2 times 5. Plus, somebody else tell me the very last thing? Yep, Ariana? We've got H times L, or 6 times 2. All right, so now we just have to go through and do out our arithmetic. Okay, let's start with what's in the parentheses, follow order of operations. 6 times 5. Sam, what's 6 times 5? 30. Good. Okay, 2 times 5. That's going to give me 10. And lastly, 6 times 2. Yep, good job, 12. All right, now we want to add up everything that's in the parentheses. I think we can do this without a calculator. What's, Gage, what's 30 plus 10?
40.
40? 40 plus 12 more?
52.
52. Okay, and my last step is 2 times 52. All right, can we do that, or do we need a calculator for that one? 2 times, yeah, if we need it, we just type it in. Yep, it's 104. And what were my units in this problem? Inches. So does anybody know how you measure area? I'm going to use inches, but somebody just said it. Square inches. Excellent. Good job. Okay, anytime you measure area, you always put the little 2 above your units. Anytime you measure volume, you put a little what? What do you do with volume? Yeah. Yeah, it's cubed. All right. If you put the wrong unit on that, it would sound kind of weird. I know it doesn't sound weird to some people, but it would almost be like if somebody said, Mr. Hager, what time is it? And I said $8. $8. I mean 8 o'clock or $8? So if you put the wrong unit on something, it doesn't sound right. All right, so square inches. All right. All right. Everyone ready for our last one? Good? All right, let's try the last one. Okay, let me make it a little bigger so you can read it. And what's the difference here? Just read it to yourself. It's similar, but it's a little different in what they're giving me. What's the difference here? Yeah.
It tells you what the area is.
It tells me what the surface area is. Okay, so we're not finding surface area. We're either going to be finding length, width, or height. Does anybody see which one of those 3 we're going to find? Kevin, you see which one we're going to find? What does it say? Just read through it. Which one is it asking you to find? The length, the width, or the height? No, it's telling me the length. It's 5 inches long. Ryan?
Right.
Yeah, find the height. All right, so we're finding the height. All right. Does everyone have that? Is that the same example that's on your sheet? Yeah, okay. All right, so you're finding the height. So what I'm going to do is I'm going to copy my formula over from the other page. Or actually, you know what? I can just leave it up at the same time. All right. So left-hand side, we're not going to have SA for surface area. We know the surface area. We're going to fill that in. Surface area is 94. All right. Next thing that comes after the equal sign, we've got our 2 times H times W.
3 times.
Okay. Corey, what did you say the height was?
3 times. Well, the height is 3.
What is this problem asking us to find?
The height.
Find the height. So we don't know the height, right? It says find the height. So how would we represent height? Yeah, we're going to leave H. Everywhere we have H in this problem, it's going to stay H. So there's our height. And Corey, what did you say the width was?
3.
3 inches wide. Okay, so 3 inches, that's your width. Plus. Okay, let's fill in what we can. How about Gabe? What's my length here? It's on your, I think it's the same one that's on your paper. Yeah, yep, 5 inches. Good, so that's my length. Okay, times what? What am I gonna put next? Yep, good, times 3. Okay, that's my width. Plus, now fill in this last part, HL. So, plus, okay, my height is what? H, we don't know it, times my L. Okay, what is my L? We just did that, yeah, 5. All right, so once you've done that step, the only thing you should have is one letter. And we do, just H. Okay, let's go through, see what we get. 94 equals, how do we normally write this? H times 3? We don't usually write it that way. So let's write it more like how we're used to. Justin, how do you write H times 3?
Like in a more familiar way, you said?
Yeah, we don't normally put the number in that position. Where do we normally put it?
Oh, right, next to the H.
Okay,
Only
it's,
not,
yeah, in front of it. So how would that look?
3H.
Good, 3H. All right, plus the next part. How about Alex? What could I do here?
Put one of them in parentheses.
You could, or you could just do it out right now. Yeah, what would you get if you do that out?
15.
Yeah, good job. 15 plus, and this last part, we have H times 5. Again, we normally don't write it that way, Alexis. 5H. All right. Next step, combine any like terms we can inside the parentheses. Logan, do you see any like terms here?
5H and 3H.
Yeah, good job. What do you get when you combine 3H and 5H? Yeah,
8H.
good, 8H. Okay, Jalen, what's still inside the parentheses? We didn't do anything with it yet.
15.
Positive or negative? Yeah, positive 15. All right, now we're finally getting down to starting to get to a smaller equation. We got to deal with this 2. Okay, anybody tell me what property we're going to use with this 2? We did it a lot yesterday. Victor? Yeah, good job. We're going to do the distributive property. Can you go ahead and do that out for me, Victor? Tell me what you get.
That'd be 16 each.
Yep, 2 times 8H is 16H. And
It would be 2 times 15. right?
2 times 15, yep,
Yeah,
30. All right, so we're getting good. We did the distributive property. Zach, is there any adding or subtracting I need to do here?
Subtract 30
Yeah.
from each side.
Good job, yep. I'm going to subtract 30 from each side. And then we're almost done with it. 94, take away 30 is how much? 64. Good job. All right. My last step, and then I will have H by itself. Yep,
Divide by 16.
good. Divide by 16. Divide by 16. And the height of this box is going to be 64 divided by 16. Yep.
4.
Yeah, if you type that in on your calculator, you'll get 4. Okay, remember our units? Now this is height. So what should the units be on the height? Think if it's an area or not. If it's not an area, we don't put the 2. Yeah, just inches, good. Height, length, width. Don't put a 2 on the unit. Area, put the 2. Okay. Any questions on that? All right, so what's the 3 types of problems we did today? What was the first one all about? Profit. So we did profit. What was the second one we did?
Distance race.
Yep, the distance, rate, and time. And what was our third one? Surface area. Good. All right, so tonight you guys are going to have a worksheet on 3-6, okay, similar to like you had last night. And don't forget our test is on Friday. Tomorrow we will finish everything we're going to do for the week. And then Thursday is going to be a review day in class.